your group today. I'm coming around with colored pencils for you and your group. The reason I think they're helpful, highlighting the parallelogram in the problem, because there's a couple four-sided figures I see in my diagram. So I think it might be helpful to highlight the actual parallelogram in your proof. If you don't want to, I don't care. I just think it's helpful so you know where you can apply the properties to. I want you to apply the properties to the correct figure. Please put these in the bin at the end. It'll be on the front desk. All right, I'd like to do some reviewing with all of you first before we even touch this proof. First piece of review. Every day we're going to do this. Properties of a parallelogram. I can't do this proof unless I know my properties. So yesterday I'd given you 5. Ready to go? I'm just calling on people here. Thank you, Lovia. Let's start it off. Properties 17. First property. Opposite sides parallel. All right, let's keep going. How about 6? Another property.
Opposite sides are congruent.
Opposite sides congruent. 20. Opposite angles congruent. And I will be honest with everyone. Those are probably the top 3 we're going to use every time in a proof. All right, we'll use those 3 a majority of the time. But I do want to go through the other 2, which are 24. Another one. Yep, consecutive angles are supplementary. I have very, very rarely seen this thrown into a proof. Consecutive angles are supplementary. Very rarely, if at all. And the last one from yesterday, 24 again. Yep. We will use this, but how can I tell I'm not even going to use this one in the proof we're doing now? Yeah, there's no diagonals here, so I can't even use that one. All right, so don't use it if there's no diagonals. All right, last thing I need to review before we touch this proof. We are going to prove triangles congruent. Methods, let's go. Methods. 12, method. Side angle side is a way I could do this. Another way, possibly, to prove them congruent. 21. 21. Side, side, side. All right, another method. 9. Angle, side, angle. All right, method number 4. 17. Angle, angle, side. And our 5th and final way, if needed. 2. How about 20? HL, only though if it's a what type of triangle? Right triangle. Forget about it if it's not. All right, good review. Now we can actually hop on this proof. I know that ABCD right here, ABCD, this is a parallelogram. This is your parallelogram, not the big one on the outside. The one I've highlighted in blue is the only one you can apply a property to. All right, I'm going to give you about a minute right now in your group not to do the proof. Find me a pair of sides or angles using a parallelogram property. A minute, go ahead. And then I'll see if any group has anything. Find a pair of sides or angles using a parallelogram property right now for those 2 triangles we need to prove. Should be go pretty quick if you know your properties.
What? Yeah.
Hopefully you can find a pair of sides or angles just using a parallelogram property.
That's not parallel. He literally just not the whole thing. So it's highlighted there.
Okay, let's get back. Let's hear from 15. You got a pair of sides or angles because it's a parallelogram. 15. Say that again. Okay, DE and FB, no go. No, everyone see that's a no go. That's not a parallelogram. It may look like it, but it's not. The one inside is. So I have to say DA congruent to CB. Pair of sides right there. All right, DA congruent to CB. All right, ready for the reason. We wrote these down yesterday. I tried to get you guys prepped for this. Parallelogram implies, Molly just gave us those two sides because she used what property? 22, what property did we just use? Opposite sides congruent. Parallelogram implies opposite sides congruent. So that just gave you guys a side. Good job. All right, can we talk as a class? How can I get another side? Because remember in the givens, it said DF equals EB, right? DF equals EB. But I need it a little smaller to get EA and CF to be equal. Anybody see anything else I could possibly use here? Still using your properties. Still using your properties. Think you got something, Molly?
You can say DC is congruent to AB.
Yep, all right, ready? Is it, yeah, I know DA and CB are, but aren't AB and DC because they're opposite? I'm not even going to make a new step, guys. I'm just going to put it in right with statement 2. It's the same reason. So right in statement 2, I'm going to say DC is congruent to AB. Same reason. Somebody else, where's Molly going with this to get me another side? Where's Molly going with this, Romeo? She's going to subtract. Yep, absolutely. We're going to take EB and subtract what from it? AB. And say that is equal to, on top, DF minus DC. This is going to get real tough now. Yeah, I got these new properties of a parallelogram and then everything I've done through the entire year. Subtraction. Okay, subtraction. And what always comes next? Yeah, okay, I'm not changing that just because we're in the 6th unit. Substitution to say, what do we got? AE congruent to CF. Another pair of sides. Great job, everybody. Great job. You got 2 pairs of sides. I need 1 more pair of something, right? And I don't think it's going to be side, side, side because we already knocked that one down. It's got to be somewhere else. I'll give you enough. It's going to be tough to see it, but you guys have enough. You have enough knowledge in here. Talk to your groups instead of trying to struggle by yourself. Let's go. Talk to your groups.
So my board, it could be angle D or D.
Talk
to each other where it's going to be.
Well, I see where you're going. Yeah. Okay, so yeah. And then you say.
And then we would say.
And you say E plus CCB and CCB and then supplements and then angles. Yeah, no, I get it. Because then you get DA are and then DA is congruent to DCB, then you could I see you're going. You hit a congruent so you can substitute. I think that's right. No, that's right. That's right.
All right, back up here. Let's talk to each other now. I heard a lot of decent things going on. How do we put it all together? What else is true about that parallelogram? What else is true about the parallelogram? I know the opposite sides are equal. I got it. What else is true? Hopefully you talked with your group and have something in mind and we're paying attention. 6, what else is true up here?
Angle D and angle B are congruent.
D and B? What do you mean by D and B? Because I got a couple angles D and B's here. I don't know which one you're talking about. Like I could do this is angle D and that's angle D right there. I think we need to get more specific than just naming it with one letter. Like, what do you mean? Where's angle D? Is it this CDA or is it EDA? I don't know which one you're talking about.
CDA.
Are we sure about that? Another minute. Talk with your group. Here we go. Here we go, guys. Guys, I'm not letting people off the hook here. This is too darn tough. Come on. This is too darn tough just to lay back and not do anything. Come on. Talk it with your group, please.
These angles in the parallelogram are also congruent. Right? It's this one? Okay.
So EDA and FC.
What are we?
Is that what we're doing? EDA and FCD.
No.
Oh wait, yeah. Wait.
Back up here. Here we go. What do we know about the parallelogram is still true about the yes, I have opposite sides congruent. What else is true about the parallelogram? 19. What else is true? Not here. Thank you. 16. What else is true here? Okay, everyone take a look. This angle right here, DAB, is congruent to DCB. Now, will those angles count as part of the triangles I'm trying to prove congruent? No, they don't count, but they are going to get me to angles that do count. All right, so let's pop that in. Number 4. Angle DAB congruent to angle DCB. That should be 1, 2, 3, 3. That should be 4. That should be 5. Reason. 10. Yep, good start. Good start. Implies. There we go. Again, they don't count, so I'm not putting an A next to it. But how do I get those angles to get to the ones next to them congruent? What's the relationship between DAB and the one next to it? Supplementary. What's the relationship between DCB and the one next to it? Supplementary. And if these two are congruent, supplements of congruent angles are congruent. Yes. So this is going to be a 2-step process. First, I need somebody. Give me one pair of angles that are supplementary. I need to write that down. Give me one pair of angles that are supplementary. 8. Angle EAD and angle DAB, yes, are supplementary. There's one pair supplementary. Give me the other pair that's supplementary. 22 supplementary. What's the other pair?
BCF and BCD.
DCB and BCF are supplementary. How do I know they're supplementary? How do I know? It used to be a reason in a piece of paper up on the board. If you don't know, that's fine. Why are they supplementary? 8. Linear pairs are supplementary. Now I can finally say they're congruent. You got the linear pairs. So let's see, I got angle EAD congruent to angle EAD and BCF. And that theorem, once again, about the supplementary angles. 6. Supplements.
Elements of congruent angles.
There we go. That is how we get the third and final pair of congruent parts. A little bit tougher. A little bit tougher here. We were struggling to begin with, and we just got tougher. And then, well, I'm not even done yet. I need a reason. DAE congruent to BCF. My reason, we just went over 5 of them. 13. Side, angle, side. 8 steps, the new norm. All right, new norm, 8 steps there. Anything we want to review? Because we only have time for another one before I let you go on your own. Questions? Okay, go. Set up the next one then. Set up the next one. It's going to be the same setup. You and your group try to find one part at a time. Parallelogram, PQRS. P. So this one, the whole thing's a parallelogram now. The whole thing is a parallelogram. I'd like to first look at the proof statement. How are we going to get SE congruent to QF? I say this all the time. You're not getting the segments congruent unless what's congruent first? You're not getting SE and QF congruent unless you get what congruent first? Triangles, right? Pick the 2 triangles we need then. All right, look at them. Look at them. There's only 2 triangles that are going to contain SE and QF. Name them so I can highlight them. 13. Name the 2 triangles I'm going to need. Oh, good job. All right, I got to prove those congruent now so I can say CPCTC. 1 minute in your group. Find a pair of sides or angles that would be congruent right now. And be ready to tell me why. I don't care if you use a parallelogram property or something else. Get me a pair of angles or a pair of sides. Go ahead. Just one.
Oh, really?
Oh yeah, we are. Hang on. Can we actually just before we do that? Can we actually put? Wait, should we put?
Okay. Going to somebody right now. Give me a pair of sides or angles in those triangles that have to be congruent. Talk me through it. 7.
PES and QFR, because they're right angles.
Okay, let's do this right now. It's going to be a 2-step process like usual. So I have angle PES and angle QFR are right angles. This is review. Perpendicular lines form right angles. And then the next step, you're going to tell me they're congruent. All right angles congruent. There's a pair of angles. Good work. 1 down, 2 to go. If we stole your groups, another minute. Go back and look for something else now. Maybe we didn't steal yours, though. Keep it then. If we didn't steal your side or angle, keep it. What else can you tell me is true about a side or an angle? Remember, it's a parallelogram. Know your properties. Talk it over. How else can I get a side or an angle congruent?
Oh, hey, we can also say yeah, only because you
S, C, and Q out.
No, congruent.
wait, we know.
It's parallel. Yeah, parallel lines imply alternate.
And then you subtract SRF and then P.
Yeah, but they have to be congruent to subtract. All right, here you go. What else do you got for me? 12. What else is true up here?
We said side SP is congruent to side QR.
Perfect. That's what I was looking for too. So we got PS congruent to QR. I like it. Why? Why are those two? Bless you. Congruent. 12 again.
Because in a parallelogram implies opposite sides congruent.
All righty. All righty. Got a pair of sides. One more pair to go, it looks like. And this is the tough part. You guys are certain to see. In question number 1, that last pair was tough because I had to do the supplements of congruent angles are congruent. Same thing in this proof. The third pair is going to be a little tough. Just because you guys aren't used to this yet. That's the only reason why. It's not because you don't know it. Just because you're not used to it. Anybody think they have something they want to share? Think you have something, Romeo? Because this is a tough one. I'll do this with you guys.
EF is reflexive, so SF.
You cannot subtract. Oh, go ahead. Go ahead.
SF minus EF is the same as EQ.
That's only true if SF and QE are congruent, though. Remember, you need 2 pairs of equal quantities. You just gave me the reflexive was equal. You also need, Romeo, SF is congruent to QE to subtract, right? Okay, and I don't have that. Okay, so I can't use subtraction there. Molly.
You can say that angle PSE is congruent to angle FQR because parallel lines imply that alternate interior angles are congruent.
That's what it's going to be. Great job. Great job. Here's what I got to say to you. From now on, what type of figure is PQRS? Okay, if you have a parallelogram, what's SQ in that parallelogram? What have we been calling that the last couple days? No. What's just the simple word SQ is? That's a diagonal. If you have a parallelogram with one diagonal, look for alternate interior angles. Look for alternate interior angles if you have a parallelogram with a diagonal. Now, just don't start writing down because, I just can't say right now those two are congruent and I'm done. What do I need for those two to be congruent? What do I need? Those two aren't congruent yet. But what do I need for them to be congruent? Luke?
You need to say SR and QQ are parallel.
I need to have parallel lines, not those though. Okay, I need parallel lines for alternate interior angles to be congruent. Now the question is, what two have to be parallel? My answer, trace the darn things out. Watch. Everyone see which two lines need to be parallel? Okay, which two then? 22, which two need to be parallel?
QR and PS.
There we go. QR parallel to PS, and that is true. That's true. I'm not making that up. That's true. Why is it true? 14, why is that fact true? QR and PS are parallel. Oh, we don't have. All right. 22, back to 22. Why is that true? That QR and PS are also parallel. It's a parallelogram, Aiden. And what are QR and PS? So what do we got? Parallelogram implies? Got it. Please tell me the lines are parallel before saying the alternate interior angles are congruent. Now we can. So angle PSE is congruent to angle RQF. A review theorem. Anybody remember it? Parallel lines, what? Imply. What type of angles? Molly gave them to us. Alternate interior angles. One last thing. Congruent. Yep. And there's your final part to proving those triangles. All right, let's say the triangles are congruent now. It's been a while here, but we got it. Let's see, PSE. Triangle PSE congruent to, if I go PSE, RQF. All right, I still need one more person here. What's going to be the reason, huh? Let's not yell it out. What reason? I got two angles and a side. Could be one of two methods. I got two angles and a side. Could be one of two methods. Which one, though? Which one? 11? Don't have one. 15? Which method am I looking at here? Yes, thank you. The side is not in between. Great job. And then finish it off, right? Now those segments are equal because of CPCTC. SE. SE and QF, CPCTC. Questions? Keep working in your group. Hey, I get it. It's easy just to go on Classroom and copy down my proof. I get it. It's not going to help anybody. And you know that. Not going to help any of you. All right, let's get going. Call me over if you get stuck. It's not always proving triangles congruent, by the way. Hi there, guys.
Can you get this to Connor Donovan in your home?
I'll do my best. You got it. You're going to have to use parallelogram properties all throughout.